Hello and welcome everyone. In this video we will see what is re-ranking, why re-ranking needed, and what are the possible ways of doing re-ranking. And re-ranking with a simple example. Okay, let's start with it. Assume one scenario: you have a database, maybe for example this one. Okay, where you have put your all the data, embeddings of your data. I would say where you keep all the stuff. Okay, and then you are querying on top of it and you are getting some results. Okay, suppose in this example we have very simple data. For example, one liner data, say a beautiful sunset over the mountains and a forest and so on. Okay, this is very simple and straightforward document list. Okay, so there is no major issue, you can get it and your output will be very accurate. Okay, so in this case there is no issue. But what if your data is little more complex, not a single liner, it's a chunk, or it's a paragraph by paragraph things. Okay, in that case, if you query, your result will not be fully accurate, or the accuracy level or the relevance level will not be as expected. Okay, to improve this, we have to make another stage. Okay, another step where we will do the further processing. Okay, to improve this result. Okay, I mean, take the output of your response of your query. Okay, and take the query also and pass it to another model, a transformer based model you can take. Okay, and pass these things and try to rank the output based upon what is the query given. Okay, for example, you pass the query, you got the response. Assume you have database having, maybe, yeah, maybe take the same example, you have 232 objects or chunk of documents. Okay, and then if you pass a query, assume the output gives you relevant output as 50 objects out of 232. Okay, now to this 50 objects, okay, or the 50 chunk of document. Okay, and a query passed his to another model which will take the input and output and try to rank it based upon the query relevance to the output, what we are getting out of 50, and it will rank it and give you the best 50. Assume, just for discussion, out of 50 maybe you are getting the 5 top best match results. Okay, so now this 5 out of 50, not out of 232. Okay, will be taken as a output, which is more accurate and more relevance. Okay, so in this way we are improving the output, what the relevant what the one single stage query and response we usually we get it. Okay, let's try to improve it by doing this second stage of processing. Okay, of course the processing will increase here. Okay, but at the benefit of getting the more accurate or more precise response. Okay, so this is the response, everyone. So let's start doing or looking at some of the possible models which can basically take the output of our query response. Okay, retrieval system. Okay, and do the re-ranking. Okay, there are many possible options available which are transformer based models. Okay, so maybe one I can show you here. Okay, this is NVIDIA and Mistral OpenAI based Mistral AI based model. Okay, the issue is here, it's a license. Okay, you have to pay for it before you use. You have to buy the license and then use it. Okay, which is not a good idea if you are building, and if it is a very huge model and you need to pay. I mean, it's a licensing issue. If you are okay with the licensing, please go ahead. Okay, or else we have other options. For example, GPT-4. Basically this model, it doesn't give the direct ranking by OpenAI, but you can reuse the model and pass your input. It will do again the ranking. For example, you have the output of your retrieval system and you have the input. Take it and convert it into a suitable form and make another prompt to the by using this chat GPT and get the response. Okay, there's no direct ranking model available, but you can do by using GPT 4 or 5. Yeah. But yeah, looking at other models like we have one more MongoDB based solution like Wedge, which is again offers some of the models. Again, there is a licensing concern, so I'm going out for the next model. Yeah, again, Gina model also available, but again, as I can say, it's a model with licensing. Okay, so in this way, like we have more options. Okay, one more saying we have cohere re-ranking model. Okay, so again, you have to buy the license to use it. So that's why I'm skipping this one as well. So let's go ahead, look at one more option, which is under MIT license. So you are free to use, and you don't have issue with the licensing. Okay, so yeah, if you are building a open source model, or if you are using or if you want to create a open source and free license free solution, then you can go ahead with this. It is also a good option, but under this option we have further more sub ranking models. Okay, so we have the large, and we have a small one and with a different language like Chinese and English, etc. Okay, so based upon your convenience, choose the one which you are interested. Yeah, so let's go ahead with our one example query. Okay, so for example, okay, here okay, I guess this font size is good enough. Okay, perfect. Okay, so we are taking Hugging Face transformer library here, and we're importing like we discussed the model. Okay, the ranker which is open source. Okay, load the model and the tokenizer. Okay, and if you are having the GPU, so this model I mean this script will check whether you have the GPU or not. Okay, if it is there, then it will switch, otherwise it will run the script on the CPU. Okay, and as an example, the query is what is the capital of the France. Okay, as a query, and possible options over here are available. Okay, like Paris is a capital, or the Eiffel Tower is a famous landmark in Paris, etc. So like in our last example, you can take a huge list of documents and push it to your vector database, over here. Okay, one as example. Okay, so and this time we are not doing, because it's just a re-ranking example. Okay, feel free to go back to my previous video where I shown you how to do this. Okay, set up the VV8 and push the data over here. Okay, yeah, so coming back here, so this time, okay, for example, we just took only four documents. Okay, now the idea is we get the response. Okay, so after that, this the response means, let me show one more time here. Okay, this the response, the output which we are getting after querying or after searching the result. Okay, this is a query, and we convert the query output into a query into a embedding vector, and then we pass to the vector database, and then we got the output. This output, okay, along with the query, okay, is here, is what I'm showing, the query and the output here. Okay, take it and pair it. Okay, first output along with I mean sub list, I would say, create a list of sub list. Okay, every sub list having query and the output. Okay, and individual output, suppose you have four outputs. Okay, then say query output 1, it will be a sublist, and a query output 2 will be a sublist 2, and so on. So we have list called pair having sublist. This format is required. Okay, and after that, just pass it to the tokenizer. Okay, tokenizer basically do two things. Okay, first it will break the complete your document. In general, tokenizer, okay, break the document into sub parts. Okay, and for every part it will try to map it to a internal vocabulary number what it has. Okay, for example, hello, basically maybe assume in the vocabulary of the tokenizer may be referring to 101, just for discussion, number, okay, a numerical number, okay, and world will be assume another number converted to a vocabulary, a number maybe 102. So my query, which is hello world, just for discussion, okay, will be converted to a numerical number, okay, like 101 and 102, okay. So this tokenization or splitting of your complete document, and then numerical number allocation, okay, will be done, okay, at the in the stage of tokenizer. And here the max length we are giving, okay, as 512, okay. This updated output will be the input for our model, okay. And since we are not going to train any model here, okay, and we don't need to retain the parameters of the model, that's why we are saying torch no grad, okay, no need to retain the information, as we don't need to do the back propagation here. We just need to get the final output, that's it, okay. For that we did a torch.nograd and then pass your input to the model and get the output, convert it the scores to a numpy format score, okay, and then just sort it, and then we are displaying the output. For example, in our query response, okay, assume if you see the most relevance is the first one, okay, we having the highest score, okay, like Paris is the capital and the most popular city of the France, okay. And there are some other responses, okay, like the Eiffel Tower is also something relevant. We have like keyword like Paris we have here, okay, here we have something France keyword, we have capital keyword here, okay, but these are having a least numbers, okay. Okay, so that way it try to it will try to give the rank, and it will try to sort and says it is most relevant is the first one, okay, and the others are having the least relevance, okay. So this will really going to help you if you are trying to create a big rag system or solution, okay. So where if your response from the first level of retrieval is very low, okay, this re-ranking will try to improve it, okay. So that's it from this video, okay. In the next video we'll try to take this as a input and try to pass it to the rag system, okay, and try to make it more better and more bigger solution. So stay tuned, and in the next video we'll see the complete rag solution, okay. Yeah, till then, have a good day. Yeah, see you, bye.